Hello students. This is Kanakam Sriram from BTech 2020 batch from first year from the electronics department. Today I'm going to teach you about surface areas and volumes. So, let's start. Exams Vidhai is a non-profit initiative of the Vidhai Society of IIITDM Kancheepuram, helping different students for free coaching and resources which can help them in different competitive exams. So let's start. So the contents of this video or this chapter which you will be learning are what are 2D shapes and 3D shapes and the surface areas of different shapes, the how volumes of different shapes, and how conversion of one shape to another. And the last thing would be frustum of a cone. Okay. In this, you will be having problem, explanation, etc. So let's start. So let's begin with 2D shape. So basically, what are 2D shapes? We know some of these 2D shapes: square, circle, rectangle, triangle. We know these are the basic 2D shapes which have we have been learning from a very young age. So 2D shapes or 2-dimensional shapes are those which can be measured by their length, width, breadth, or height. Yeah. So for a square, we'll see the side lengths. For a circle, we'll see the radius. And for a rectangle, we'll see the length and the breadth. So, but the thing we need to remember about these are they are completely flat. And an important note over here is 2D shapes have only area and no volume. The reason is that they are completely flat and live only on a two-dimensional space. Yes, let's go to the next. 3D shapes. What are 3D shapes basically? We see in our everyday life cube, sphere, cuboid, and cylinder. We also see cone, which we see in ice cream cones, and also the birthday hats. So these are the basic 3D shapes which we know in our real life. So what are these 3D shapes? So 3D shapes or 3D-dimensional shapes are basically solid shapes. They have 3 dimensions: length, breadth, and height. Here, height is nothing but the depth, and breadth is nothing but the width. They just occupy some space as matter. So we see in this cuboid, they have length, they have breadth, and they have height. Whereas this sphere, it has volume and it is occupying some space. Over here, we see cube has three different sides in three different directions. Whereas cylinder, we see this is the height and a circle having a radius. But one important thing to note about 3D shapes is 3D shapes have both surface area and volume. This is an important thing. Unlike 2D shapes, 3D shapes have volume and surface area, whereas 2D shapes have only surface area because they are completely flat. Whereas these are not completely flat, they are solid shapes, they are solids. Yeah. So let's see about the surface areas of different shapes. So basically, surface area it is divided into two: lateral area and total surface area. Lateral surface 2D shapes. Lateral surface is nothing but the normal surface area of any solid object or 2D shape. So 2D shapes over here have only one surface area because they are completely flat and they do not have any volume. So for 2D shapes, the lateral surface area and the total surface area are the same. Hence, they have only one, that is area. Whereas 3D shape, they have both LSA and TSA, that is total surface area and lateral surface area. The LSA, or it's also called the CSA for some of the shapes which are having curve like cylinder. The lateral surface area of the 3D shape is the area of the non-base faces where CSA is same, but for curved surfaces like cylinder or sphere or hemisphere and cone, because it also has a curved area. Whereas total surface area is the total area of any solid object or solid shape, including the bases. Yeah. So total surface area are all the bases and also all the faces. Yeah. So let's see now surface area formulas of some of the 2D shapes. Yeah. For square. So area of a square is nothing but side into side. That is this side into this side. Okay. And for a circle is nothing but pi into r square. Pi into radius of the circle, whole square. Whereas for a rectangle, it is length into breadth. Whereas for a triangle, it's not particularly defined, but for majority of the triangle, it's half into base into height. Whereas specifically for an equilateral triangle, it is root 3 by 4 into side square. Okay, now let's see the surfaces area of 3D shapes. So first, let's see of cube. So the LSA of cube is 4 into side square because it has 4 sides other than the top and the bottom. Okay, those are considered as the bases. Yeah. So total surface area of the cube is 6 into side square because it has 6 faces including the top and the bottom. So next, let's see of cuboid. LSA of cuboid is 2 into h into L plus b. Here h is the height and L is the length and b is the breadth. Whereas total surface area of cuboid is 2 into LB plus BH plus HL. That is sum of the areas of all the 6 faces. Whereas for a cone, it's different. It is CSA because it has a curved area. So the CSA of cone is pi RL, where L is the slant height of the cone. Total surface area of cone is the curved surface area plus the base area of the cone. Here, base area of the cone is nothing but area of circle, whereas curved surface area of cone. So pi r square plus pi r into L plus r. So now let's see of a sphere. The curved surface area of a sphere is 4 pi r square, and the total surface area of sphere is also 4 pi r square, because the total surface area and the curved surface area is same. It has no bases and no faces. Whereas for a cylinder, the curved surface area is 2 pi rh. Here h is the height and r is the radius of the basis. Whereas total surface area of the cylinder is curved surface area plus 2 times the base area, because it has two bases which are in the shape of a circle. So it is 2 pi rh plus 2 pi r square, that is 2 pi r into r plus h. Now let's see of a hemisphere. Hemisphere's curved surface area is 2 pi r square, and the total surface area is 3 pi r square, because in 2 pi, because the curved surface area is the curved part, that is 2 pi r square, that is half of the sphere, whereas the total surface area is including the base, that is 3 pi r square. So 2 pi r square plus pi r square, that is area of the base, total 3 pi r square. So now let us understand more about surface areas by solving a problem. Okay. So here it is given that two cubes, each of volume 64 centimeter cube, are joined end to end, and find the surface area of resulting cuboid. So here this is one cube and this is the other cube. So we know that the volume of a cube is side into side into side, that is side cube. So volume of a cube is side cube. So each cube has a volume of 64 centimeter cube. When they are combined, we are getting a cuboid. So first of all, we need to find the length of the side of the cube, so that we can find the total length of the cuboid and the height and the width or the breadth. Yeah. So side cube is equal to 64. You are equating it because it is volume of the cube given as 64. You get the side as 4, as cube root of 64 is 4. And then we understand that the side is of length 4, whereas when it forms a cuboid the total length becomes 8 centimeter, because each cube has a length of 4 centimeter, whereas the breadth is 4 centimeter and the height is 4 centimeter. Then we know that the surface area of resulting cuboid is 2 into h into L plus b, that is LSA of cuboid. So when we substitute the values, we get it out as 72 centimeter square. Let's look at another problem of surface areas. So let's read the question first. First, Rashid got a playing top Latto as his birthday present, which surprisingly had no color on it. He wanted to color it with his crayons. The top is shaped like a cone surmounted by a hemisphere. The entire top is 5 centimeter in height and the diameter of the top is 3.5 centimeter. So find the area he has to cover. It means we have to find the total surface area of the solid object. So here the solid object is the top, Latu. We know that we have been playing in our childhood with Latu by tying a rope around and trying to leave it so that it's keep on s- spinning. Yeah. So now first we have to identify what all different shapes the Latu is made of. So it makes us easier to calculate the total surface area of the Latu. So here the Latu is made of two, that is a hemisphere and a cone. So the total surface area would comprise of the curved surface area of the cone and the curved surface area of the hemisphere. Whereas we can't take the total surface area in order to calculate the total surface area of the Latu because we are not able to see their bases. Only we have to calculate their outer area, not the inner area. So let's start by calculating the slant height of cone. So the slant height of cone is calculated by L equals to h square plus r square, square root of h square plus r square, where h is the height of the cone and r is the radius of the cone. So we know that the diameter given here is 3.5 centimeter. So radius would be 3.5 by 2 whole square plus 5 square whole square root, which comes out to be 3.7 centimeter approximately. So in order to calculate the total surface area of the toy, we need to calculate the curved surface area of hemisphere and curved surface area of cone. So we know that curved surface area of hemisphere is 2 pi r square and curved surface area of cone is pi rl. So we calculate as follows. And one important thing here is he asked us to take pi as 22 by 7. So we take pi as 22 by 7 and we substitute the values and calculate. Here it makes us easier to cancel by taking pi as 22 by 7. Calculating the above, we get the total TSA of the toy as 39.6 centimeter square. So one important note over here is, as I already told, you may note that total surface area of the top is not the sum of total surface areas of cone and hemisphere, but the total surface area observable of the object. So guys, thanks a lot for attending the first session. I'll be continuing this topic in the further session with volume of differentiate. Thank you.